If a cycling animal does not get pregnant, then the active corpus luteum, which maintains the high concentration of progesterone in circulation, has to regress in order to allow a new process of folliculogenesis. The mechanism triggering the regression of the corpus luteum is based on permitting that prostaglandin F2 alpha gets to the ovary, where it would cause the destruction and subsequent attrition of the functional corpus luteum. The mechanism that triggered the regression of the corpus luteum in the sow is understood to be as follows. By day 15 of the cycle, two parallel events take place. First, large luteal cells of the corpus luteum start secreting oxytocin, and second, the endometrium of the uterus start expressing receptors for oxytocin. Oxytocin released by the corpus luteum travels through circulation and reaches the uterus, where it binds the respective receptors. As a result of the activation of the oxytocin receptors, the endometrium secretes prostaglandin F2 alpha. This hormone is drained by the uterine vein, which, in a special anatomical structure, is wrapped by the ovarian artery, permitting that some of the prostaglandin F2 alpha flowing through the uterine vein crosses the endothelial cells of the uterine vein and then the ovarian artery, entering into the flow of the ovarian artery. Through this counter-current exchange mechanism, some prostaglandin F2 alpha reaches the ovary, where it causes the destruction of the corpus luteum, apparently by reducing irrigation to the CL, thus depriving it from oxygen and nutrients. This countercurrent exchange mechanism is essential given that prostaglandin F2 alpha is a molecule very labile, and most of them are destroyed when they reach the lungs. Once the corpus luteum starts to regress, it ceases the production of progesterone and becomes the corpus albicans, which translate in a decrease in circulatory concentrations of progesterone. The decrease in circulatory concentration of progesterone removes the blockade that progesterone exerted on the development of new follicles, thus permitting the process of folliculogenesis to proceed. This will result in the elevation of circulatory estrogens. At its highest concentration, estrogen will trigger a massive release of gonadotropin-releasing hormone, which in turn will cause a spike of luteinizing hormone which will modulate the ovulation of the next crop of mature follicles.